Now let us just say we can have a practical example, and in that practical example, let us suppose we do have this, we can say, uh, shear face, or we can say a simple shear connection. And let us say this is the steel column, and we are watching this as an elevation, and this is basically the steel beam, which we want to directly weld here to make a shear connection here. Or in a separate view, we can draw it something like this. So let us say this is the steel column, and this is basically the steel I-beam. And what we need to do is that we do need to weld this all around to make a shear connection. Usually when the length of the weld is that much high, it is better that we can proceed with this kind of intermittent fillet welding. So this ensures that the steel beam does not bend or does not locally warp in the case of, we can say, extremely high temperatures at the time of the welding. So let us assume that the shear force that is acting here, that is approximately, let us say, 500 kilonewton, and the length of the weld, the total length of the weld, that is approximately, we can say, 1000 mm, or we can say 1 meter. So the shear force that is coming on this particular weld, that is approximately 0.5 kilonewton per mm. So considering that 0.5 kilonewton per mm, we can do the reverse calculation. How we can do that? Let me just show that with the help of this particular example. So design weld shear, in our case, that is approximately 0.5 kilonewton per mm. Fillet size, thickness of the weld, that we can assume as, we can say, 8 mm. And welding category basically, as per AS 4100, we had already studied that either it is general purpose or structural purpose. For the type of connection that we were discussing here, where it is an extremely important for stability, we can say that we definitely need to proceed with the structural purpose. But as we had discussed that for structural purpose welding, we do have to do the stringent quality checks, that is X-ray test, or we can say dye test, to ensure that welding that we are doing is correct. Throat thickness, we had already studied that whatever fillet size that we are getting, we do need to multiply it with 0.7. So that gives us throat thickness of 5.7 mm. After that, electrode type. We do know that these are different electrodes that are available, and as per table 9.6.3.10a, uh, E43, E49, or E55. These are the different types of electrodes that are commonly available in Australia. So considering E43 grade, we do know that the nominal weld strength of that particular electrode is 430 MPa. For E49, the electrode strength is approximately 490 MPa, and for E55, the electrode strength is 550 MPa. So usually for structural purpose, this 550 MPa electrode is used because that is the higher strength electrode metal. After that, length of the weld we had already considered as 1000 mm, and basically that is to find out the value of the Kr. Let us say if this value is 2000 mm, there is a reduction for welded lap connection, that is 0.98. So whatever value that we are getting, we have to multiply it with 0.98. So as in our case, we had considered 1000 mm. So in our case, Kr value is 1. The simple formula to calculate the welding capacity is this particular formula. That is 0.6 multiplied with the FUW, that is a nominal, we can say, weld strength of the metal, multiplied with the throat thickness, that is 5.7, multiplied with the Kr, that is 1. So we can find out these values here. That is 0.6 multiplied with 550 multiplied with the thickness of the throat, that is 5.7 mm, and again multiplied with the Kr, that is 1. So we do need to divide it by 1000, that is 1.881 kilonewton per mm. And after that, what we need to do is that we do need to multiply it with the capacity reduction factor. That is, in our case, it is 0.8. So the value comes out to approximately 1.5. In that case, approximately 1.493. So more or less, the values are same. So the concept that I'm trying to convey to you is that, as we had, in the other lecture, we had discussed about the simple calculation of the, we can say, bolt capacity, similarly we can find out the simple calculation, the welding capacity also. So it's just a simple case. Let us assume you are doing 6 mm thickness weld. Let us suppose. So for 6 mm thickness, we have to multiply it with 0.7. So 6 into 0.7. 4.2 mm is the throat thickness. Multiplied with the, we can say 0.6. That is this particular value. Multiplied with the, we can say FUW. That is the welding strength of electrode. Let us assume it is 430 MPa. And multiplied with the KR. And we can say divided by 1000. So that value comes out to approximately 1 kilonewton per mm. So we can enter this values here, 6 and electrode type as 3. So what we need to do is that again, yeah, so we do need to multiply it with 0.8 also. So 0.867 and 0.876. So uh, that is how, we can simply calculate the capacities with the help of the simple calculator also. There's no as such, complicated formulae that are used to calculate the welding capacity. So obviously, there are other concepts also, because that is just a basic, walk around to calculate the capacities. There are, we can say, other issues that we had already, discussed, like the weld group capacity, or we can say the type of the welding, fillet welding, butt welding. So all those parameters also needs to be, thoroughly reviewed and holistically considered, so that the calculation that we are doing is correct and in line with what the drawings that we are providing at the site.